I'm running the 1/3 horsepower Rotovertor motor. It's drawing 180 milliamps and 120 volts. It was down to 170, but now I have a 6 UF, a 4 and a here and a 2 here, and they're in parallel. And this is the cap size you want to use while it's just at idle, nothing on the shaft. And watch, I'll pull off, I'll make it 4 UF and I'll not have this in parallel, so it's 4 UF, not 6. Now draw goes up to 250 milliamps. So I'll put this back on. Now it's back to 180. So when you tune a rotovertor, you want to go up and down 1 UF at a time. If I go 7 or 8 UF, it'll also be higher draw. If I go below it, it's higher draw. So this is the cap size you want to use. Now, the run cap phase, you know, this is a 3-phase induction motor. And you're running it on single phase. And the run cap, there's that leftover phase, you could call it, the virtual phase, rotary transformer phase, run cap phase. It's all the same thing. It's the third phase of the motor that's not being powered, really. And so that's where the run cap goes across. L1 and L2 receive the power from the grid. L2 and L3 have a run cap across it. And you might need a start cap to get it going. This one actually doesn't even need a start cap. I just use the run cap. I have ceramic bearings in it right now. This motor was running on 30 milliamps, not 180. Made a lot of noise, and I took it all apart, put it back together, redid the bearings, and now it's at 180 milliamps. And I took the rotor out and reversed it, and it's still the same. I thought that might do something. Anyways, here's what's interesting whenever you work on a rotovertor. Circulating, I have a ammeter in series from the L3 line to the cap. There's the L3. And I put an ammeter in series so I can see what the amps is circulating. And it's 500 milliamps. That's pretty good. And then I also have a voltmeter across the run cap phase to see what's circulating in voltage. Now this isn't amps. I mean, this is not watts. What the power is circulating through there. Now, watch, I'm going to take off this, I'm going to go make it only one, take it out of the proper run cap again, and I'll make it 4 UF by taking this out. And again, now the draw goes up, and look what happens to the run cap phase. It used to be 500 milliamps circulating, now it's only 150. See that? And the voltage, voltage came off just a little. Okay, sorry. Now I'm looking at the voltage across the run cap phase, 115 now, and it's only 150 milliamps. And the draw is at 250 milliamps and 120 volts. And this is because it's a 4UF cap. It's the improper run cap UF of the run cap. Now I'm going to put it back on. Now it's 6UF, and I guess you'd call this resonating. I don't know if that's the correct term, but this is what you want. Now, again, with the correct UF run cap phase, run cap UF, it's now again 180 milliamps input. It's now 175 volts, and it's a great big amount of current circulating. That's 500 milliamps. So if you're going to be taking power out of the run cap phase and running a load with it or doing something, you want to make sure your caps are correct, the best possible for the best output. That's quite a difference, 150 milliamps compared to 500 milliamps circulating. So, just wanted to show that. Sorry about the squealy sound. I usually have this inside a bin, insulated sound, and I want to run that. I'm working up to spinning this with a rotovertor at 1800 RPM. I have a feeling the magnets are too close together to go that fast, so I might have to pop every other magnet out so there's not 16 but 8. And these are all north facing. Might need to go north-south, north-south, north-south all the way around, but maybe this will work fine. Maybe this will work great. It'll be like almost pure DC, no collapsing field. I don't know. All I know is to have to test it. So, here I go. I have another motor that goes 3600 RPM, same size, same brand as this. And it's running really good. So I can test this both at 1800 and 3600. So I guess that's it. Thanks for watching.